Hello everyone, my name is Yaduraj Singh and I am here to present you all my rocket design Vajra. Vajra is modeled to accomplish my target of safe, high velocity and altitude launch while carrying heavy volume payload and maintaining in-flight stability. Now I will go over the blueprint of the model. Vajra stands at a height of 16 inches and weighs around 1 kg 200 grams. The center of gravity is located at 8.49 inches, situated at the center of the model. The center of pressure is situated at 11.34 inches, approximately 3 inches behind the CG. Now I will will go over various components of the design. The nose cone. The nose cone is 4 inches long, 2 inches wide, and made of polished basalt structure of the Hack series of rocket cones. These dimensions were chosen to maximize the inner volume to house the inner structure which is responsible for handling the payload. This was chosen to belong to the Hack series of nose cone as the shape allowed the model to easily cut air drag and maximize velocity and altitude reach while maintaining inflexibility. The payload. The payload is modeled to be a heavy object 4 inches long, 1.5 inches wide. These dimensions allow to engage in many types of course of mission, thus increasing its versatility. Vajra is able to lift a payload range of 400 grams to 771 grams while maintaining in-flight stability. It can even carry higher payload exceeding 1 kg, but it will not adhere and fit to the limitation of the max weight. Body. Vajra's body is polished basalt of length 7 inches, outer diameter 1, inner diameter 0.8, and a wall thickness of 0.1. These dimensions were taken to allow all internal parts of Vajra to be housed properly. Furthermore, the body is designed to be thin and make it possible for making to make a boat in. Parachute. The model is outfitted with two different parachutes to meet the requirement of Vajra. Parachute A. This is composed of 32 inches wide diagonal canopy and has 10 shroud lines of length 12 inches. This is set to deploy at apogee. Parachute B. It is composed of 39 inches wide diagonal canopy and has 10 shroud line of length 2 inches. This was set to deploy at apogee. This allows Vajra to achieve a safe grounding speed of 2.74. Motors. Vajra motor module is composed of dual clusters G11, G11.5, 13A13 rocket motors situated at the side of the module and hosted in two side tubes, fin and bow tail. Vajra has three sets of fin, two fin shape two free shaped fin designed in such a way that it is able to support the unusual side booster and by maintaining stability by increasing lift and cancelling the unwanted vibration and rotation. Then this fin structure further enhanced by the bow tail on which it is placed. The bow tail allows the streamlining of model, thus reducing the air resistance and maintaining stability. Technical challenges. The unusual side booster led to the unusual bad position of the CP. For example, the CP was positioned above the rocket. This was overcome by the increasing the surface area of the fins and adding mass to the nose cone. This solution worked as adding mass to the nose cone moved the CG upwards, and by adding surface area to the lower part of the body lowers the CP. Um, The side booster's position also made it impossible for conventional placement of fins. This was solved by splitting the fins into three sets of two fins, then placing them systematically. The third problem was that I wasn't able to add nose cones on the side booster because it wasn't possible to add nose cone in open rocket. Static margin. As CP is the average of all projected areas, so adding fin surface area moves the average area back. As the rocket moves around the CG, but the area acts on CP, so the torque is created by CP around the CG that will rotate the rocket in line with the airstream till the CP is exactly behind the CG, and this makes us rocket stable. Practical feasibility. This rocket is able to perform wide areas of mission with high speed mission and heavy load missions. Vajra is also is easily Vajra can also easily be used as either a single stage rocket or double stage rocket. Now for the performance. I'm gonna launch my rocket in really low wind speed and good weather conditions. As you can see, the graph of stability time margin, the rocket flight lies between a good stability of 1.57 to 1.2.5. This rocket flight is really stable and is and now for the next one. With the payload of 500 grams, the rocket achieves of an apogee above 200. And just a minute. Uh, uh, the in the now with for the performance, when uh, when the payload is edited for more for my like 771, the max possible. Yeah, and it is able to move 559 meters above the minimum apogee required. As you can see, with the maximum payload of 771, it is able to reach the height altitude of 1559 meters, and while uh, and the and still having a ground speed of ground hit ground speed of 2.74 meters per second. Now let's go of the lowest possible around um, lowest possible payload of 450 and still be stable, as well as going more than two times of the required apogee around, and it is the apogee is 2233. Getting an apogee of 2333 meters, or max max velocity of 236 meters per second, max rotation of 213 meters per second, time to apogee is 21 seconds, and flight time is 149 seconds. Ground velocity is really low as 260 and 268 meters per second. Um, Flight side profile, launch all, stability was time. As you see in this is the rocket is still stable around from 1.5 to 235, still in the stable margin as and still having low ground speeds. um, Ground. With the maximum possible payload that does not go above the max weight is 772 grams, and it still goes up and still goes to the apogee of 1558 meters. Normally, I will fly the rocket at 1 kg of payload, and it goes above, more than above the double is around 2,114 meters, and with have the mass is 1,228 grams. Thank you for the watching, and please the performance is really well in this rocket, but I wasn't able to add the nose cone because Open Rocket does not allow me to. Uh, so this is my rocket, and thank you.